Hi everyone! In this video, I will be going over the USACO problem breed proximity. I'll begin by summarizing the problem statement. There are n cows which each have their own integer breed ID. If two cows of the same breed are no more than k positions apart from each other, they are considered to be crowded. We basically want to compute the maximum breed ID of a pair of crowded cows. So let's look at the sample test case given to better understand the problem. So in the sample input, we're given n equals 6 cows and that k equals 3. So basically, a pair of crowded cows must be no more than 3 positions apart. The cows' breed IDs are 7, 3, 4, 2, 3, and 4. So in this case, there are two pairs of cows with the same breed ID that are crowded. The cows with breed ID 3, and they have a distance between them of 5 minus 2, which is equal to 3. And the second pair of crowded cows is the cows with breed ID 4. And the distance between these cows is, again, 6 minus 3, so it's equal to 3. And so in this case, the maximum breed ID is 4. So we would return 4 as our answer. So when we're approaching this problem, let's begin by thinking of the brute force solution. And so basically, an easy way to do this problem would be to check every single possible pair of cows and check to see if number 1, they have the same breed ID, and number 2, if they're no more than k positions apart. And if both conditions are met, then we know that we have found a valid pair of cows, and so we can just keep track of the breed ID of that pair, and we can store it in an array or a vector, and then at the very end, we can just find the maximum breed ID out of all of the ones we have stored. And so basically this approach, again, would require checking every single pair of cows, so it would involve a nested for loop, so 2 for loops from 0 to n. And so again, we would just check if the ID of I is equal to the ID of j, and if the position of I minus the position of j. So basically, if the absolute value of this is less than or equal to k. And again, if this condition is true, and also if the indexes of I and j are not equal to each other, then we know that we have found a valid pair. So this definitely is a valid solution. However, let's look at the time complexity. Since we have a nested for loop, and so we're iterating through each cow, and then for each cow, we're iterating through every single cow again, the time complexity for this would be O of n squared. And if we look at the constraints, n can be up to 50,000. So basically, that means we could have a possible up to 50,000 squared operations, which ends up being 2.5 billion total operations. And so again, going back to what I've mentioned before, a general rule of thumb for USACO problems is that you generally never want to have to do over 500 million operations. If we have to do over 500 million operations, that typically means that we're going to run out of time, and so we're not going to be able to get all of the test cases. And so basically, we want to find a more efficient way to solve this problem. Okay, so if you think about it, we essentially want an efficient way to check if two cows with the same breed ID are no more than k apart from each other. And so to easily group the cows with the same breed ID together, we can simply sort the cows by their breed ID. And it would make most sense to sort from greatest to least. And the reason why is because we want to find the maximum breed ID of a pair of crowded cows. So if we iterate from greatest to least breed IDs and we find a pair of crowded cows, then we would have our answer already. We would not need to check the rest of the array. And so we can simply stop the loop and print out the answer. So in this case, keep in mind that there are actually two things we want to keep track about a cow. We want to keep track of their ID, and we want to keep track of their position. Because based on their position, we can figure out if a cow is too close to another cow with the same breed ID. So based on this, we definitely have a good reason for using a struct. We can store both of these characteristics, an ID and the position of a cow. And we can simply sort the cows based on their IDs from greatest to least. Okay, so here I have the sample input sorted from greatest to least based on ID. And so here we can just see that it's super easy to iterate through and find the answer. Essentially, within a loop, we can iterate through and check for two things. Number 1, if the current element's breed ID we are on is equal to the previous element's breed ID. And number 2, if the difference between their positions is less than or equal to k. So for example, if we were to go through this array, we would start off with 4, and then we would check, is 4 equal to the previous breed ID, 7? It isn't, so then we would go on to the next element. And so here, is 4 equal to 4? Yes, they are equal. And is the difference between their positions less than or equal to k equals 3? And it is. So here we've immediately found a pair of cows that meet these two conditions, and therefore we have our answer, which is just 4, the breed ID. And so the time complexity of this solution would be O of n log n because of the sorting. And so it seems relatively simple, and it seems to be fast enough. However, there's also one more thing that's important to consider. Let's say we were to have 6 cows, so n is equal to 6, and k equals 1. And 4 of the cows have the same breed ID of 1, and 2 of them have the same breed ID of 2. And let's say we were to sort these cows based on breed ID from greatest to least, as we already discussed. And so this is something possible we might end up with. And notice that as we iterate through and we compare each cow with its previous cow, we never get a difference between the positions of cows with the same breed ID that is less than or equal to k equals 1. Because the difference between these two cows is 2, the difference between these two cows is 4, the difference here is 2, and the difference here is 3. And so here it would initially seem that there are no pairs of cows that match this condition of number 1 having the same breed ID and number 2 being less than or equal to k apart. However, if we look more closely, there is actually a pair of cows that satisfies these conditions. This cow over here and this cow over here. These two cows have the same breed ID of 1 and they have a difference in positions of 1. However, they weren't placed right next to each other. And so here we can see that position does seem to matter. And so let's update our sorting strategy to reflect those changes. So we're still going to sort from greatest to least based on ID. However, the second thing we want to do is that if the IDs of 2 cows are the same, we will sort based on position. And so in this case, we guarantee that we're looking at the minimal differences between the positions of these cows. Okay, so with that, let's go on to the code for this problem. I'm going to be going over the code for this problem now. And the first thing I'm going to do is I'm going to create a struct called cow that contains 2 variables, one to represent the ID of a cow and one to represent the position of the cow. So the next thing I'm going to do is I'm going to create an array of cows, and then I'll also create the variables for n and k. And so I'm going to input everything in now. So I'm inputting each of the IDs for the cows, and I'm using array of i.id, and then I'm also adding the positions for each of the cows, and I'm just doing I plus 1. Because I starts at 0 and then it increases by 1 every time. So the next thing I want to do is I want to sort this array. And so again, we want to sort first by the ID and then second by the position. So let me just write out the basic structure for the sort function. So I'm going to do sort array plus n, and then we want to write our Boolean comparator function. So I'm going to do bool compare. And so we're comparing 2 cows, so 2 elements of type cow. So I'm going to do cow A and cow B. And so within this function, we know that if the 2 breed IDs are equal, then we want to sort based off position. So we can do if A of ID is equal to B.ID, then if A of position is less than B of position, then that means we want to put A before B, so then we would return true. Otherwise, we would return false. And so if the 2 cows do not have the same ID, then we want to sort based off greatest ID, so from greatest to least ID. So we would just do if A of ID is greater than B of ID, then we know that we want to put A before B, so we would return true. Otherwise, we would return false. Okay, so now let me add the compare function as a third argument to our sort function. And so again, when we're using the sort function, make sure that you have #include algorithm at the top. So now the next thing I want to do is I want to iterate through the array, and I'm going to start from int I equals 1 all the way up to n. And so within this for loop, I'm going to be checking if the current element we're on is equal to the previous element, and if the position difference between the 2 elements is less than or equal to k. And when we meet that condition, then we can just see out the ID of the current element we're on, because that means we have found the maximum breed ID of 2 cows that are crowded. So if array of i.id is equal to array of I minus 1.id, and if array of i.position minus array of I minus 1.position is less than or equal to k, then we would see out the current ID we're on, and then we would wait. And so that concludes the code for this solution. And if we were to submit this to the USACO website, we should get that it works for all test cases.